Before we actually do this material, it's important to understand the concept of free fall. In physics, when you guys took physics last year, we talked about projectile motion. And what I want to talk about is not type 1 and 2 and 3, and it gets very complicated in trigonometry and all those sorts of things. But what I'm going to talk about today, I'm going to introduce you to it, and then I'm going to make a playlist where we want to talk about type 1 projectile motion. And it's very easy. Type 1 projectile motion. So, as some background to satellite motion, there's two kinds of background you need for satellite motion that you haven't had in physics. And I'm going to give you a little bit of background. And the two things you need to understand are, one, projectile motion, type 1 projectile motion, and circular motion. That's it. Clear? Easy? Those are the two things you have to know as background. And we're going to teach it, and you're responsible for it, etc. However, you're not necessarily responsible for it. It's not very heavy duty, and it's actually based on only a few equations, and the math is fairly straightforward, etc. Clear? But there's a physical concept here, especially with projectile type 1 motion, that the physics students will find, or any student, introductory physics student, will find curious, kind of almost counterintuitive, almost in a sense. Yeah? And that is this. And we've talked about this already. If I take some kind of missile, a stone or a gun or something, clear? And I shoot it off a cliff, and horizontally off a cliff, right? And at the same time, I take a stone and I drop like that to the ground. Okay? This first one will go like this, and the second one will go like this. Okay? Now, the idea is this, and this is kind of the screwy thing, that this stone will hit the ground at the same time that this projectile hits the ground. Okay? Right? Okay. The initial downward velocity is going to be what? What's the initial vertical velocity going to be? Yeah?
9.8. No, never mind.
Oh, no. Let me put that down. 9.8 meters per second squared. Is that what you're going to say?
Yeah.
Okay. First of all, we use 10 meters per second squared, and that's going to equal the acceleration. Okay, so you're maybe confusing the acceleration, and that's okay. It's typical. It's not a problem. So that's the acceleration, right? So after 1 second, how fast is it going to be going? Let me read to you what this means. This means that it's going to gain a velocity of 10 meters per second. Let me write it out. In other words, it's going to say 10 meters per second every second. Isn't that what it says? Okay. Now, how do you get seconds squared? Well, remember in the old days when you were in elementary school and you learned division for the first time, and you learned the connection between division and multiplication. And you said, okay, what is 1/2 divided by 1/4? And you'd look at yourself and say, I have no idea. Now you know that it's 2 is the answer, right? Because there's 2 quarters and a half, right? So 1/2 divided by 1/4, right? Okay, now, but how were you taught to convert that? How were you taught to do that functionally? Yes? Very good. Multiply by the reciprocal. So what you did was, you converted that and said, it's going to be the same thing as 1/2 times the reciprocal of 1/4 is what?
4.
Is 4. The reciprocal of 1/4 is 4. So 1/2 of 4 equals 2. So that's the way you were taught to do that. Now the same thing is true here. I would say this is 10 meters per second times, reciprocal of second is 1/2 second. And that's going to be meters per second squared. Clear? Meters per second squared. Yes? Okay, now. So that's where you get the squared. So in other words, what it's saying is, right. The initial velocity is what? What's the initial velocity? What's the initial velocity? The initial vertical velocity, what is it? What is it?
It's 0.
Yeah, I'm dropping the stone. Sophia, right? I'm dropping the stone. And I'm going to drop that stone and at the same time shoot. Boom! Right? So the initial velocity of that stone that's falling vertically is going to be what?
0.
It's going to be 0. So after 1 second, the stone is traveling what velocity? 10 meters per second. Clear? You get that? Yes or no? Okay, now. So, and then, if it's dropping for 4 seconds, it will hit the ground going what velocity? 40 meters per second. Okay? All right, now. This is what projectile motion is. Type 1. This is type 1. Type 1 projectile motion. You clear? This is what it is. You ready? It says that this horizontal motion is independent of the vertical motion. But its trajectory is affected by it. In other words, you could draw the vectors in, and then we're going to be finished. You ready? So you could say that this motion, let's say that's the size of the vector. That horizontal motion, that vector, never changes. Whatever it was here, it's going to be the same all along here. The same size. So when that hits the ground, it's going to be going that fast. It doesn't change. It remains constant. According to Newton's laws, and we've been over this. Is that on there?
Yes.
Okay. What happens is this starts out 0, right? And then every second, that gains, that increases because of what? Gravity. Very, very good. We just did chapter 13. Excellent, Amanda. You are on fire today. You are on fire. I'm so glad you didn't do the bake sale. The bake sale people are kind of like off, you know? Okay? So when it hits the ground, it's going that fast. Clear? Yes? Starts off at 0. Amir, sit down. Amir, sit down. Thank you. Appreciate that. No, you may not. Okay? You get it? Yes or no? Okay? Now, what we have to do is we have to determine if I just give you a velocity and a height, I have to determine several things. How fast it's going when it hits the ground, right? Yes? And how far it goes. Clear? You get it? Very basic. Trust me when I tell you, I know everybody in here by now. Everybody will get 100 on the one and only Type 1 projectile motion quiz. We're only having one. It's not worth any more time. It's very simple. And everyone will get 100. Clear? Let's go to the planetarium.
Is that the explanation for circular orbits?
That's not for circular orbits, but that's a start. That's a start. Okay? The question was, everybody, is this for circular orbits? No, this is a start. This is what you need to know this first for circular orbits. Clear? Because now if the Earth were the cliff, the top of the Earth were the cliff, and I shot the projectile out, what would happen? It would curve and actually miss the Earth, but it would orbit the Earth, right? You get it?
It was following towards the Earth.
Exactly.
that much minutes.